me, Revy Pesigan from Team 111. Sulat kayo, no? Makabungat ng camera. By the way, we are here to present to you our tutorial video. And what we plan to cover in our video includes a variety of subjects, namely central limit theorem, Z-test, T-test, C-test for proportion, C-test for two proportion.
But first, I would like to tell you a brief background information about statistics. Statistics is the practice of collecting and analyzing numerical data in large quantities, especially for the purpose of inferring proportions in a whole from those in a represent active sample.
But first, before we start, let us hear from Lawrence Butiu to familiarize ourselves with the symbols that we are going to use.
Now people, these are the following symbols one must remember. Here we go!
This symbol means sample size and refers to the value of the sample. This another symbol means sample mean, which refers again to the sample. The population mean refers to the population. Is the sample standard deviation for the sample. Sample proportion refers to the value of the sample. Population standard deviation is the value of the population. The symbol for population proportion refers to the value of population. This is for probability of success, refers to binomial distribution. Represents a specific observed data value that refers to the sample. Represents a random variable and all possible value that refers to the population.
Topic number 1. Central limit theorem. What is central limit theorem? Did you know that this statistical proportion is most commonly seen in our daily life?
Example number 1. In a survey of a company, the mean salary of the employee is $29,321 with standard deviation of $2,120. Consider the 100 employees and find the probability their mean salary will be less than $29,000. Step 1. Identify the given values. Total number of employees 100, mean 29,321. Standard deviation 2,120. Random variable 29,000. Probability X is less than 29,000. Step 2. Substitute all the given values to central limit formula, which will be the answer is negative 1.51. Step 3. Normal distribution table. Since we have to find result for less than, so we will take this left side of negative 1.51. Step 4. Find the z values in the z table. Z equals negative 1.51 has an area of 6.55%. Step 5. Conclusion. Therefore, we can conclude that the probability of employees having mean salary less than $29 is 6.555. Example number 2. The number of hours spent playing video games a week by the residents of General Trias, Cavite has a mean of 10 hours with a standard deviation of 6 hours. If you select 25 random residents, find the probability that the hour of playing video games of the residents is greater than 12 hours. Step 1. Identify the given values. Total number of residents 42, mean 10, standard deviation 6, random variable 12, probability n is greater than 15. Step 2. Substitute all the given values to central limit formula, which will be equal to 1.62. Step 3. Normal distribution table. Since we have to find result for greater than, so we will take the right side of 1.62. Step 4. Find the z values in the z table. Z equals 1.62 has an area of 94.74%. Since we have to find the result for greater than, let's subtract 94.74% from 100%. The answer is 5.26%. Step 5 conclusion. Therefore, we can conclude that the probability of the hours of playing video games of the residents of General Trias Cavite that is greater than 12 hours is 5.26%. Example number 3. There are 10 dogs at a dog show who weigh an average of 12 pounds with a standard deviation of 8 pounds. If 6 dogs are chosen at random, what is the probability that the average weight of dogs is between 8 pounds and 25 pounds? Step 1. Identify the given values. Total number of males equals to 10, mean equals to 12, standard deviation is 8, random variable is 6. Step 2. Substitute all the given values to central limit formula, which will be equal to 2 answer equals negative 2.36 and negative 0.75. Step 3. Normal distribution table. Since we have to find result for in between, so we will take the area of between negative 2.37 and negative 0.75. Step 4. Find the z values in the z table. Z equals negative 2.37 as an area of 0.89% and 0.75 negative has an area of 22.66%. Since we are finding the result for between, subtract 0.39 from 22.26%. The area between negative 2.75 and 0.75 negative is 21.37. Step 5. Conclusion. Therefore, we conclude that the probability that average weight of dogs is between 8 pounds and 25 pounds is 21.37%.
Well, did you learn anything? Topic number 2.
What is Z-test? As a student, this greatly helps in solving dilemmas. Problem number 1. A researcher reports that the average income of an OFW family is more than 25,000 pesos. A sample of 40 OFW family has mean income of 30,000 pesos. At alpha is equal to 0.10 and standard deviation of 9,500, test the claim of the researcher. Given mean is equals to 25,000 pesos. N is equals to 40. X bar is equals to 30,000 pesos. Standard deviation is equals to 9,500 pesos. Alpha is equals to 0.10. Step 1. The hypothesis statement. HO is equals to mean is greater than or equal to 25,000 pesos. HA is equals to mean is less than 25,000 pesos. Step 2. The level of significance or the alpha is equals to 0.10 and the problem is one-tailed. Step 3. The Z value. Using the table, find the appropriate Z value that corresponds to 0.10 or the alpha. Z is equals to 1.282. Step 4. Solving for the Z value. The formula is equals to Z is equals to X bar minus mean over standard deviation over square root of N. This formula will be applied to all problems of this kind. Substitute the values and then solve. 30,000 minus 25,000 over 9,500 over square root of 40. Z is equals to 3.33. Step 5. The normal curve. Mark the Z value attained from step number 3 and shade accordingly. Since the problem given is greater than, the right side must be shaded. Look for the Z value. If within the shaded region, HO must be rejected. If within the non-shaded region, HO must be accepted. Since the Z value is within the rejected region, we reject the HO. Step 6. Conclusion. Since we reject the HO, we can conclude that there is enough evidence to support the researcher's claim. Problem number 2. A researcher reports that the average income of an OFW family is less than 50,000 pesos. A sample of 50 OFW family has an average income of 55,000 pesos. At alpha is equal to 0.01 with a standard deviation of 25,000 pesos, test the researcher's claim. Mean is equals to 50,000 pesos. N is equals to 50. X bar is equals to 55,000 pesos. Standard deviation is equals to 25,000 pesos. Alpha is equals to 0.01. Step 1. The hypothesis statement. HO is equals to mean is greater than or equal to 50,000 pesos. HA is equals to mean is less than 50,000 pesos. Step 2. The level of significance or alpha is equal to 0.01. It is one-tailed. Step 3. The Z value. Using the table, find the appropriate Z value. Z is equals to negative 2.326. Step 4. Solving for the Z value. Z is equals to X bar minus mean over standard deviation over square root of n. This formula will be applied to all problems of this kind. Substitute the values and then solves. 55,000 minus 50,000 over 25,000 over square root of 50 is equals to 1.41. Step 5. The normal curve. Well, in our problem, the given is less than. The left side must be shaded. Look for the dissolved Z value. If within the shaded region, HO must be rejected. If within the non-shaded region, HO must be accepted. Since the Z value is within non-rejection region, we accept the HO. Step 6. Conclusion. Since we accept HO, we can conclude that there is enough evidence to support the researcher's claim. Problem number 3. A researcher reports that an OFW family has an average income of 35,000 pesos and is different from the national average of 40,000 pesos. With a sample of 30 family, at alpha is equals to 0.05 with standard deviation of 15,000 pesos. Test the researcher's claim. Given mean is equals to 40,000 pesos. N is equals to 30. X bar is equals to 35,000 pesos. Standard deviation is equals to 15,500. Alpha is equals to 0.05. Step 1. The hypothesis statement. HO is equals to mean is equal to 40,000 pesos. HA mean is not equal to 40,000 pesos. Step 2. The level of significance or the alpha is equal to 0.05. It is two-tailed. Step 3. The Z value is equals to positive or negative 1.960. Step 4. Solving for the Z value. The formula is Z is equals to X bar minus mean over standard deviation over square root of n. Substitute the values given. Z is equals to 35,000 minus 40,000 over 15,000 over square root of 30. Z is equals to negative 1.87. Step 5. The normal curve. Mark the Z value attained from step number 3 and shade accordingly. Since the problem given is equal, not equal to, both sides must be shaded. Look for the dissolved Z value. If within the shaded region, HO must be rejected. If within the non-shaded region, HO must be accepted. Since the Z value is within the non-shaded region, HO must be accepted. Step 6. Conclusion. Since we accept HO, we can conclude that there is enough evidence to support the researcher's claim.
And that's all. Let us greet the next commentator.
Topic number 3.
What is t-test? Statistics have proven itself useful in our everyday life again and again. T-test is just another example of it. A statistician reported that the annual income of a chemical engineer is roughly 54,750 pesos. Mary Sue claimed that it is false. With 27 chemical engineers, she yielded the average of 52,450 pesos with a standard deviation of 3,376 pesos. At level of significance 0.05, test if there is enough evidence to support Mary's claim. The first thing to do is to identify the given values necessary in solving the problem. The givens. Mu, or the population mean, is equal to 54,750. S, or standard deviation, is equal to 3,376. Sample mean, or X bar, is equal to 52,540. N is equals to 27, and level of significance, or alpha, is equal to 0.05. The given problems may be identified as two-tailed or one-tailed. It is considered one-tailed if there is the presence of clue words such as greater than or less than and other such variants of it. It may then be considered two-tailed if there is the presence of clue words such as equal to or not equal to or other phrases that may hint to it. Step number 1. The hypothesis statement. HO, or null hypothesis, is equal to mu equals to 54,750. HA, alternative hypothesis, is equal to mu not equal to 54,750. If the given problem is identified as two-tailed, the HO, or null hypothesis, must always possess the symbol equal to. In this case, our problem is identified as two-tailed. Step number 2. In this particular type of problem, the step number 2 is comprised of stating the level of significance and the degree of freedom. Alpha, or level of significance, is equals to 0.05, identified as two-tailed, and the DF, n-1, in this case, 27 minus 1 is equal to 26. Step number 3, z-value. Using the table, find the appropriate z-values. Since we have identified that the problem is two-tailed, it must be plus, minus, or positive and negative. Z is equals to plus minus 2.056. Step number 4, solving for the z-value. The formula for this is z is equals to x bar minus mu all over quantity of s all over square root of n. We must now then substitute the given value to the formula. 52,540 minus 54,750 all over quantity of 3,376 over square root of 27. All of it is equal to negative 3.54. Step number 5, the normal curve. Mark the z-values attained from step number 3 and shade accordingly. Since the problem given is equal or not equal to or two-tailed, the left and right side must be shaded. Look for the solved z-value. If within the shaded region, HO must be rejected. If within the non-shaded region, HO must be accepted. Since the z-value is within the shaded region, we must reject the HO. Step number 6, conclusion. Since we reject the null hypothesis, it can be concluded that there is not enough evidence to support Mary's claim. Now let's move on to the next problem. If the given problem is identified as one-tailed, read the problem carefully and indicate the claim at age A. Since the problem is identified as one-tailed and the claim is less than, Z in step number 3 must be equal to the negative value. Problem number 3 may be seen as one-tailed since we can observe the presence of the clue phrase greater than. In this scenario, age A or alternative hypothesis must be indicating mu is greater than the specified value. And since the claim is greater than, in step number 3, we must choose the positive value of the identified Z value. And that concludes the test. Now let us welcome the next speaker.
Topic number 4. Z-test or proportion. What is Z-test?
There are many things to consider before deciding upon which statistical test to use. This lesson will ensure you that you can easily tell if one is using Z-test for proportion.
A researcher wishes to determine the proportion of college students who failed at least one subject in the current semester. He determined that from a sample of 120 college students, 24 failed a subject. Is it valid to infer that 20% of college students failed at least one subject? Use level of significance 0.05.
First thing to do is to identify the given values necessary in solving the problem. For P, we have 20% or 0.2. For Q, which is 1 minus P, we have 0.8. For N, we have 120 college students. And for P hat, which is X over N, we have 0.2. Step 1. The hypothesis statement. For null hypothesis, we have P is equal to 20%, and for the alternative hypothesis, we have P is not equal to 20%. Step 2. In this problem, we are asked to use 0.05 level of significance, and this is two-tailed. For step 3, 0.05 level of significance give us the Z critical of 1.960. Step 4. Solving for the Z value. This formula will be applied to all the problems of this kind. Substitute the values and then solve. This gives us the answer 0. Step 5. The normal curve. Mark the Z value attained from step number 3 and shade accordingly. Since the problem given is two-tailed, 1.960 on both sides must be shaded. Now we are going to look for a solved Z value which is 0, and as we can see, it lies on the non-rejection region, meaning we do not reject HO. And for the conclusion, since we do not reject HO, it is valid to infer that 20% of college students have at least one failed subject. Problem number 2. A psychologist is interested in investigating the proportion of depressed teenagers in a particular city. Using a sample of 40 teenagers, 16 were found to exhibit symptoms of depression. At 0.01 level of significance, test the claim that more than 35% of teenagers who live in the city are depressed. Let's identify the given values necessary in solving the problem. For P, we have 35% or 0.35. For Q, which is 1 minus P, we have 0.65. For N, we have 40 teenagers. For P hat, which is X over N, we have 0.4. For the hypothesis statement, for the null hypothesis or HO, we have P is less than or equal to 35%. And for the alternative hypothesis or HA, we have P is more than 35%. In this problem, we are asked to use 0.01 level of significance. This is an example of one-tailed problem. 0.01 level of significance gave us the Z critical of 2.326. The same formula will be applied. Substitute the values and then solve. This gives us the answer 0.663. Step 5. The normal curve. This is going to be right-tailed because we stated in the alternative hypothesis that P is more than 35%. So we will shade the right side of 2.326. Now we are going to look for a solved Z value, which is 0.663, which lies in the non-rejection region, meaning we do not reject HO. Step 6, for the conclusion, since we do not reject HO, we can conclude that there is not enough evidence to support the claim that more than 35% of teenagers suffer from depression.
Problem number 3. The teacher claimed that less than 50% of her students passed the examination. In a sample of 46, 22 students passed the said exam. Using 0.05 level of significance, can the teacher's claim be proven? Let's identify the given values necessary in solving the problem. For P, we have 50% or 0.5. For Q, which is 1 minus P, we also have 0.5. For N, we have 46 students. And for P hat, which is X over N, we have 0.478. So for step 1, for the null hypothesis, we have P is greater than or equal to 50%. And for the alternative hypothesis, we have P is less than 50%. Step 2, in this problem, we are asked to use 0.05 level of significance, and this is an example of a one-tailed problem. 0.05 level of significance gives us the z-critical of 1.645, and since the alternative hypothesis state that P is less than, our z-critical will be negative. Step 4. The same formula will be applied, substitute the values and then solve, and this will give us the answer negative 0.298. For step 5, this is going to be left-tailed, and we will shade the left side of negative 1.645. Now we are going to look for a solved Z value, which is negative 0.298, which lies in the non-rejection region, meaning we do not reject HO. For step 6, for conclusion, since we do not reject HO, we can conclude that there is not enough evidence to support the claim that less than 50% of the students passed the exam.
Get it? That is how we answer this type of problem.
Topic number 5.
What is Z test for two proportions? Without any further delay, let us begin.
Example number 1. The teachers teach two groups of students who are studying the same subject. In the first group, 30 students were selected, of which 11 failed the quarterly examination, while in the second group, 10 out of 24 students failed. At alpha 0.01, is it valid to conclude that the rate of failure in the first group is less than in the rate of the second group? The given for this problem are N1 is equal to 30 students, N2 is equal to 24 students, X1 is equal to 11 students, X2 is equal to 10 students, P1 is equal to 0.37, P2 is equal to 0.42, Q1 is 0.63, Q2 is 0.58. Step number 1. The hypothesis statement. Null hypothesis. P1 is greater than or equal to P2. Alternative hypothesis. P1 is less than to P2. Step number 2. At alpha 0.01, the level of significance and 1 tailed. Step number 3. Since we identified already the level of significance in the tail we are going to use, the critical value for this problem is negative 2.326. Step number 4. Solving for Z value. The formula for this problem is P1 minus P2 all over to the square root of P1 times Q1 over N1 plus P2 times Q2 over N2 is equal to the Z-score. The answer after calculating through the use of formula is negative 0.75. Step number 5. The normal curve. Mark the Z value that we attained from step number 3 at the normal curve. Since it is negative, it should be on the left side of the normal curve, which is negative 2.326. Next, plot the z-score that we computed at step number 4 and find out if it is on the rejection area or the non-rejection area for HO. For this problem, we must accept HO since negative 0.75 is within the non-rejection area for HO. Step number 6, the conclusion. Since we accept null hypothesis, we can conclude that it is not valid to support the rate of failure in the first group is less than the rate of the second group.
Example number 2. Suppose you have two groups, a male and a female group. Choosing a sample of 50 from the male group, you have identified that 15 are licensed to drive. On the other hand, a sample of 60 from the female group showed that 24 are licensed to drive. At alpha 0.05, do the data provide sufficient evidence to conclude that there is a higher percentage of licensed drivers from the male group? Let's identify the given for this problem. N number 1 is equal to 50, N number 2 is equal to 60, X number 1 is equal to 15, X number 2 is equal to 24, P number 1 is equal to 0.30, P number 2 is equal to 0.40, Q number 1 is 0.70, Q number 2 is 0.60. Step number 1, the hypothesis statement. Null hypothesis, P1 is less than or equal to P2. Alternative hypothesis, P1 is greater than P2. Step number 2. For this particular problem, the level of significance that we are going to use is 0.05 and one-tailed. Step number 3. Since we already identified the level of significance and the tail we are going to use, the critical value for this particular problem is 1.645. Step number 4. Solving for z-score. Using the formula for two sample proportions, the answer for this problem is negative 1.14. Step number 5. The normal distribution. For this problem, we can see that negative 1.14 is already within the non-rejection area for HO, so we must accept HO. Step number 6. The conclusion. Since we accept null hypothesis, we can conclude that the data doesn't provide sufficient evidence to conclude that there is a higher percentage of licensed drivers in the male group. Example number 3. In Region 4A, 60 out of 103 private schools surveyed subscribed the publisher B senior high school textbooks. In NCR, only 50 schools out of 90 private schools surveyed. At alpha 0.10, is there significant difference between the proportions of subscriptions in Region 4A and NCR? Let's identify the given for this problem. N number 1 is 103, N number 2 is 90, X number 1 is 60, X number 2 is 50, P number 1 is 0.58, P number 2 is 0.56, Q number 1 is 0.42, Q number 2 is 0.44. Step number 1. The hypothesis statement. Step number 2. For this particular problem, the level of significance that we are going to use is 0.10 and two-tailed. Step number 3. Since we already identified the level of significance and the tail that we are going to use, the critical value for this problem is positive and negative 1.645 since it is two-tailed. Step number 4. Computing for z-score. Using also the same formula for two sample proportion, the answer for this problem is 0.28. Step number 5. The normal distribution. Since we use two-tailed, we can see that the both sides of the normal curve is shaded at positive negative 1.645. But 0.28, our z-score, landed within the non-rejection area for HO, so we must accept HO. Step number 6, the conclusion. Since we accept HO, we can conclude that there is no significant difference between the proportions of subscriptions in Region 4A and NCR. This is the last of our tutorial lesson.
your turn. Here's a challenge for you.